Hi, everyone. My name is David Penalva. I'm the co-founder and CEO of Heliovolta. We're the developers of SolarGrade, a fieldwork and technical asset management platform. First of all, I want to thank Rated Power and the team and everyone organizing the event. This is awesome. It's always lovely to come to my motherland, all the way from San Diego, California. I thought I was coming from far away after seeing Chris coming from the Philippines. It's like, okay, some others here. Anyway, today I'm going to be talking about fieldwork and why that can help elevate asset care. Actually, I have the remote, sorry. Okay. So the way I like to start is why fieldwork, right? Why I decided to dedicate most of my career into fieldwork. And everything started when I got involved into some thermal events associated to solar PV plants. I was very unfortunate events. I was digging as a technical advisor into the root cause analysis on some of these events. And when trying to dig into the documentation from what was done in those projects during operations or even construction, I realized that there was no way of really digging into that data. It's like, where is this data? How is it being stored? And really realized the importance of having that fieldwork well documented. So that's what triggered me dedicating like this time to developing technology for fieldwork events. I also, like for non-technical people, when my mom asked me, it's like, hey, what do you do? I try to explain it a simple way with an analogy of a car. If you're buying a car, you wouldn't buy a car just based on the mileage of the car. You want to kick the tires, you want to drive the car, you want to see the maintenance records of the car, and that has more value. It's not the same buying a car from a used car from someone when they come to you with all the documentation properly organized in a folder versus someone that doesn't have any documentation, right? That car has higher value. So that's what we're trying to do, elevating asset care by utilizing the data that comes from the field, which can enhance data acquisition, SCADA data, and performance data, complementing that data. So I'll talk first about the reality of fieldwork. Like, I don't know if you guys have been out there working in the field. It's rough. Typically, these projects are built in remote locations. You're spending long days in the field. And on top of that, you have pressure to document all the work that you're doing. So one of the photos there of myself, like looking at the back of the solar model, there's a hot junction box. You could not see that from a thermal drone scanning, for example, and all the work that gets done in the field. In the end, someone has to go to the field and actually fix the issues, even if you're able to get that data from somewhere else. A little bit of my background and myself, I've been working in the solar industry for almost 17 years now, worked on projects all over the world. I started in Spain and moved to the US. Most of my career has been in the US. And I conducted myself many inspections for different projects at different stages of project life cycle. But when I say fieldwork, what do I mean by fieldwork? I mean any type of interaction that someone has when we're going through, whether the construction of the project to the operations and maintenance. Any type of QA/QC during construction, golden rule, mechanical completion, substantial completion inspections, to commissioning or preventive or corrective maintenance work. With regards to the data and why that data matters, like there are things that the SCADA system is not able to see, and the personnel on site usually have a pretty good idea of what is going on. So we're logging issues associated to, for example, connectors, which is a big problem in the industry, as we're realizing as well. Wire management, related terminations, snail trails, and other type of issues associated to collected in the field. SCADA data is limited. It typically gives you visibility up to, there are 3 points of communication typically, meteo stations, inverters, on meters. And outside of that, you're kind of blind on what's going on. You see that there is underperformance, but you really don't see what is behind that underperformance in a lot of cases. And That translates in some cases, the lack of field data could translate into some of the catastrophic events that we've seen, as some of the fires out in the news, which is not great for the industry. The sense of solar not being safe. Solar is extremely safe when built properly, maintained properly, and properly documented. As well as there is a report from Kilowatt Hour Analytics that came out last year that shows that the average project underperformance in the US for utility scale is 8%. So it's a lot of things that we need to work on, and a lot of the insights come from collecting that data in the field. So what is the solution? The solution is empowering our field technicians and engineers to be able to collect data in a faster way and bring it back to the office to make decisions. So this is why we created SolarGrade, fieldwork and technical asset management platform that allows you to digitize the field experience, bring it back to the office, automate reporting and documentation, and being able to help you with automate punch list and data analytics that will help business intelligence in your company. And now I'm going to be talking about some of the insights from solar fieldwork. I just explained why it matters, but I'm going to show you how this looks like from the analytics perspective. So what we did is we published last year a study white paper that covered hundreds of solar projects in the US and Puerto Rico, where we looked at 60,000 data points of fieldwork data points collected, and these projects were ranged from 150 kilowatts to 300 megawatts distributed across the US. One of the first things that we noticed is that projects that were COD'd in the US in 2020, so projects that started production in 2020, had a higher volume of issues when normalizing the data. And one of the explanations for that, in 2020, it was the end of the ITC in the US, which is the incentive tax credit. So there's a lot of projects that get rushed to being connected by the end of the year, and everyone, plus COVID, that probably didn't help. So we saw a lot of shortcomings in a lot of those projects. Here we see, and this is one of the shocking results, when we looked at the data of issues based on the severity of the issue, we saw that 62% of the projects inspected had major or critical issues. When we talk about major critical issues, those are issues that cannot wait until the next preventive maintenance inspection to be addressed. So these derive into de-energization of the system, partial or total, or corrective maintenance work right away. So most of the issues were on the critical and major were located in the DC distribution, which looking at the data from the location within the system, we see that this distribution, again, is one of, if you really think about what a solar project is a DC distribution system connected to an inverter and then going through an interconnection point. So we have visibility on the inverters, so those get addressed very quickly by the O&M teams when you get alarms from the SCADA system. But then once you get into the day-to-day work, those unattended issues usually underline the DC distribution. So we saw racking, PV model, inverters as the other locations. When looking at the top 20 categories, specific categories within all these sections, we can see that field-made connectors, these are connectors that are used at the home runs, they call at the end of the strings. Typically, those need to be made in the field. They have been a huge problem, at least in the US, as well as we see wire management, conduits, raceways, trackers, and microcracks on PV models. So these are some of the data gatherings that we got from. We were able to even dig into the category of connectors itself and kind of break down the issues by the type of root cause. In this case, we had improper installed connectors, cross-mated and exposed to elements as the top 3 issues. When looking at data associated to the inverters, we see that 2 inverter manufacturers were almost responsible for 40% of the issues. This data is normalized by manufacturer, and these are issues that are not necessarily related to alarm failures. These are issues that could be any, improperly torqued terminations or hot spots within the inverter or water ingress within the inverter. So these are the type of issues that we're talking about. This data, again, collected by field technicians that are doing either O&M or construction oversight or QA/QC. As a takeaway here, as an industry, I think we need to do better to achieve safer and reliable PV systems. So fieldwork data matters. It really enhances performance data from the data acquisition systems. Third-party QA/QC, I would say that is essential based on a lot of the data that I've seen and the work that it's done over the years. And we have to empower our field technicians and qualified professionals, which are a bottleneck in the industry. One of the key topics, I attended the Solar Asset Management Conference last week in San Diego, and I think in Europe I heard the same thing. We have a huge problem with qualified personnel building the systems, operating the systems, so we need to empower those teams that are working in the field. It's already a hard work what they're doing, but gathering that data enhances asset owners and having visibility on performance and educating the measurements to be able to avoid these problems in the future. So again, this is part of digitization and applying technology and tools that we have today to be able to empower our teams in the field. And with that, that's it. Thank you, everyone.